Welcome to the Vision by Protivity interview. I'm Joe Kornik, Director of Brand Publishing and Editor-in-Chief of Vision by Protivity, our new quarterly content initiative where we put megatrends under the microscope and look far into the future to examine the strategic implications of big topics that will impact the C-suite and executive boardrooms worldwide. In this, our first topic, the future of cities, we're exploring the evolution urban areas are undergoing post-COVID and how those changes will alter cities over the next decade and beyond. And we've got a good one for you today as I'm joined by Konstantinos Karagiannis, Associate Director of Quantum Computing Services for Protiviti. When we talk about how technology will impact the future of cities, we certainly need to include quantum computing in that equation. Simply put, quantum would enable problem-solving capabilities involving a number of variables and potential outcomes at amazing speeds not attainable with conventional computers. Quantum-inspired algorithms could bring innovative solutions and approaches to product development, reduce time to market, optimize customer delivery, and speed up data transfers. But what impact could it have on the future of cities around the world? For that, I'm bringing in our expert, Konstantinos. Konstantinos also hosts the Post-Quantum World podcast. Thanks so much for being here, Konstantinos.
Yeah, thanks for having me.
Okay, so this is a big topic. So let's level set for just a minute if we could. We've sort of been hearing a lot about quantum computing for a few years now. So what is it? Where are we in it, sort of the maturation stage? And how far have we come to this point?
Yeah, so quantum computing uses the mysterious nature of quantum mechanics to do a type of computing that was never possible before. So with quantum computing, it's not just about building a computer that's faster, but it's also about building a computer that does things in an entirely different way. Most people are familiar with classical computing, where you have binary, that's zeros and ones, that allow computation. In quantum computing, we have something known as a quantum bit, which, thanks to superposition, can be both 0 and 1 at the same time. And it sounds weird, it doesn't sound like a big deal, but with the right algorithms written to take advantage of that, you can do things that have been impossible in the past, or will become impossible just because of size. So dealing with a lot of data is a lot easier for a quantum computer. A classical computer, every time you try and improve it, it's a very linear progression. People know Moore's law. Classical computers get more powerful every couple of years or so. They double every couple of years or so. Quantum computers, though, if you just add one of those quantum bits I told you about, you've just doubled the power of the machine, just to give you an idea how those things get explosively powerful over time. So we're still a little bit in the early days as far as maturation. We haven't been able to prove a usable quantum advantage just yet, but we're on the cusp. In fact, it could come as soon as this year that we'll be able to prove some practical application that is just done better by a quantum computer, even today, even with the machines we have now. And what's next would be taking these machines and making them even better. And we have plenty to discuss about that today, I'm sure.
Okay, so when we talk about cities specifically, where do you see the biggest benefits of quantum computing as it relates to sort of cities?
Yeah, so those algorithms I told you about, that if you have them to take advantage of the machine, they're going to allow some pretty impressive things to happen in the space of cities. So the big three with quantum computing is basically anything involving optimization, anything involving machine learning, or anything involving simulation. And all three of these things apply to cities. The biggest one we're going to see first would be optimization, because there's a type of quantum computer called an annealer. And if there's certain types of problems that already, if you apply an annealer to them with a little bit of classical assistance, so you sort of have like classical computers doing some of it and then the annealer doing the quantum part, we're already starting to see things that are approaching advantage. So for example, you can do an experiment where, let's say you have a city that has had some kind of catastrophe and they need to distribute goods to multiple locations in the most efficient way. We've already seen experimentation done on D-Wave's hybrid system, where a classical machine learning algorithm would try and find the best approach to deliver those goods. And it would take let's say 27 miles of driving to get them to all the locations. And then the quantum computer was able to figure out paths and timing and everything to do it in only 20 miles of driving. So from 27 miles to 20 miles, that's pretty decent, and you can imagine how that would start to explode if you added more variables like weather or avoid this street because of crime or whatever. Quantum computers just do really, really well at handling larger and larger amounts of data. So we expect this type of thing to hit all avenues of smart cities, all types of planning with optimization, just regular delivery routes, the classical traveling salesman problem people have probably heard about. It's this idea of true efficiency. And to me, a smart city is not a smart city if it doesn't have perfect efficiency, right? Then it just becomes a complicated mess with traffic jams and all sorts of things like that. Then you move on to like the pure machine learning side. Anywhere the machine learning is going to touch a smart city, it'll just be better with quantum given time. We've already seen the extrapolation of this happening. So anytime you're trying to make intelligent decisions or automate processes, you'll find that a quantum computer will be able to do things in thousandths of the time that it would take a classical machine. And then eventually it gets even more exaggerated. What's fascinating is this isn't going to be like a neck and neck arms race with classical and quantum. Whenever quantum proves advantage in an area, it'll just that'll be it. It'll be almost like a straight line up. If you think about like graphing its performance, it'll never be like classical could catch up again. Just add one qubit and you've doubled the system, et cetera. So over a course of a few years, quantum computers are going to seem to be practically magical at the things that they excel at. And then on the simulation side too, we see massive impacts of that affecting cities. You'll be able to do sort of like simulations about risk, simulations about how things will literally go. Building materials can be improved by simulating which types of molecules handle stresses better. Basically anything where you want to try and make a guess about how a certain flow on any given day will be in the numerous intricacies of a city, quantum machine learning algorithm will just be much, much better.
I've read quite a little bit about sort of this quantum apocalypse that's coming. I guess that means the day when quantum computers will be able to crack encryption, which that certainly sounds bad. And I know on the smart city side, there's quite a few concerns around cybersecurity, but I would imagine that this is sort of on steroids. So tell us a little bit about that, the quantum apocalypse, and tell us, how bad could that be, and what could it mean for cities, and what can be done about it?
Yeah, way back in 1994, Peter Shor, a mathematician, came up with an algorithm that showed that we'd be able to reverse two very large numbers that were used to make an even larger number, which is basically the secret behind RSA and other types of public key encryption like elliptic curve. So once a quantum computer gets powerful enough, which could be 5 years away, it also depends on like if we can link them together. Sometimes they might be able to do work more efficiently in the future. It remains to be seen. So when that happens, all the old ciphers rather, because of this algorithm, will be able to be sliced apart. This will affect Bitcoin too and other cryptocurrencies. So for a smart city to excel, it would have to build in what we call post-quantum cryptography. NIST is currently working on new math-based ciphers that can replace RSA. So within 3 years or so, we expect to have fully approved and vetted new ciphers that can be put in place to avoid that quantum apocalypse. So building a smart city, it would be smart to already consider from now having the crypto agility needed to build those ciphers in.
Yeah, interesting. You mentioned a couple of time frames there. You mentioned a few years out from that. The speed of all of this, I mean, it seems a little mind-blowing to me, at least, a mere mortal. Can you put together like a sort of a timeline, short term, of where we'll be maybe in a few years in terms of quantum computing and cities? And then, I mean, I know this is a little bit of a riskier proposition when talking about something that moves at the speed of quantum, but can you even hazard a guess as to what could be possible, say, a decade from now?
Yeah, absolutely. I talk about quantum timelines all the time with our customers. Some of them are concerned just about the crypto apocalypse we were talking about. So for them, the timeline is like just from now, start looking at being able to adapt to have these new post-quantum solutions in place. But in general, they're also concerned about how soon they can see real benefit with quantum. So this is kind of how I see the timeline from what these aren't even just guesses. This is sort of like based on roadmaps and things from the people making the machines themselves. Within this year to next year, we're going to actually see true quantum advantage in areas of optimization because of the amazing work being done with annealers. So that type of quantum computer is already getting pretty mature. It can only solve certain types of problems, but when mapped correctly, we're already seeing we're just about there. For example, like we could do portfolio optimization now, where if we were picking how to like invest money, it might not be as accurate as classical, but it'll be literally 1,000 times faster. So once we tweak the accuracy, we have advantage. So there's all sorts of little like tweaks and things like that have to be made. So we're going to see that with smart cities too. If anyone wants to apply optimization back to any kind of NP hard type of problem, like a traveling salesman going everywhere without repeating your steps, we're going to see advantage of that area within a year. So this is the beginnings of like the benefit to a smart city, and it's already here. About 2 years from now, in 2023, we expect to see multiple 1,000 qubit and up machines. And those are going to start to do really amazing things in the other type of quantum computing or gate-based. So that's where you're going to see explosive benefits to doing quantum machine learning, quantum simulation, like I talked about. So that's really exciting how close that is. You know, like around 2023, I imagine there's going to be a headline generating paper almost every week talking about how now we can do things so much better than we did before. So that's just 2023. And then by 2024, we'll start seeing more interconnects and links and the ability to connect quantum computers together to have them behave as if they were one machine. So it's not like when you're trying to do grid computing now that you're doing little pieces of a problem and then sending the answer. You'd almost be able to think of all of them as one machine, kind of sending calculations in progress over special connections for this quantum sort of internet. So that's really, really soon, 2024, 2025, we should start seeing explosive growth in the power of the machines because of that interconnect capability. And then as far as a decade goes, I would say, I mean, Google already has announced that they plan on having fully error-free quantum computers by 2029. So that's definitely within the decade. Once that happens, quantum computing, there aren't even going to have to be any technical hurdles really to making it work. It'll sort of be like, is it a type of problem quantum is better at? You just effortlessly encode it and really make it run. It should be quite an amazing time. The interfaces for programming are getting better too. So I can see that within a couple of years, it will be possible to just apply quantum in multiple areas without having to like build it from the ground up every single time. So this is really the most exciting time. That's why we're putting so much focus on it here at Protiviti.
Right. Will we see like actual like when we move around a city in 2030? Will we have noticeable differences, or will it be so baked into sort of everything that's happening around us that we won't be able to see it in action?
Yeah, because the areas that it touches are gonna make the big changes themselves. I don't know if people will be aware of what's happening. So, I mean, we all see how machine learning, AI in general has made life a lot easier, right? They're going to notice that AI all of a sudden magically got a whole lot better, practically overnight in some areas. And I don't know how aware people are of this all the time, but anything that they thought AI was doing a decent job at, all of a sudden it's going to be doing a really great job at. So just that could impact everything from like autonomous vehicles. They'll just have that better sort of grid backup or brain that is giving them the extra information they need to make better decisions. A city will be more hyper aware of these cars that are moving through it, for example. It'll be able to give more real-time feedback and make predictions about where a car will be in a few moments and plan for it. So quantum might make possible those terrifying images you see of cars shooting through intersections without any traffic lights because they're all autonomous and slicing out of each other. As much as I love this technology, I don't know if I want to be in one of those cars.
Yeah, it's going to be interesting to say the least. Konstantinos, before I let you go, can you tell us a little bit more about the Post Quantum podcast that you recently launched?
Yeah, yeah.
Where can people find it, and what can they expect from it?
Yeah, it's on all the platforms. You could just search the post-quantum world. And every episode, I talk to a company, a person, a representative, a researcher, someone who is having a big impact on quantum today. We've already had some of the big machine makers like Honeywell. We've had like Microsoft, who has their Azure Quantum platform where people could code. So it has like a business focus too. So anyone listens to it's going to hear about the technology and what's emerging and what's new, but also what it means to them, what it's going to mean to, in the case of Bitcoin, like what it would mean to basically, what if cryptocurrency was cracked by quantum computer, and everything to, hey, what are the use cases? What are the things that my company can start getting benefits from immediately or in the near term? So we try to cover it all and make it somewhat understandable.
Yeah, I've given it a listen. It's fascinating stuff. And thank you so much for your time today. Konstantinos Karagiannis, our Associate Director of Quantum Computing Services for Protivity, where he's out there fighting the fight, helping our clients on a day in and day out basis, facing the future with confidence.
Thanks.
Thanks, Konstantinos.